This is a national emergency.
Detonator charged.
Sio story ya jaba.
Si story za jaba. Makofi hapo kama sio story ya jaba.
Kenya's nuclear program is as real as the sun rises from the east and sets in the west, because it was conceptualized in 2010 and we've been doing quite a lot. According to Kenya's energy plan, the least cost power development plan, nuclear is set to come on board in 2034.
2034.
Yes.
Okay.
Today, as we speak, I'm sure we see the number of times we have load shedding in our country and blackouts. And we must recognize that Kenya is a net importer of electricity. We are buying electricity from Ethiopia and Uganda. We want to be self-reliant in terms of our energy needs, and so as to guarantee that we have reliable, safe, secure, and affordable power. And therefore, the 2034 date is something that the government is working at earnestly to ensure that we meet it. So we hope to start construction in 2027 and the president to be able to commission the first nuclear power plant in 2034. Then there's the question about why nuclear. I think that is a very important question, and it's a real question that we need to interrogate. We have solar, wind, hydro, and geothermal, and those are very beautiful sources of energy, clean and so forth. But we are saying that we want to industrialize as a country. We need baseload, power that can support our industrialization aspirations. And therefore, nuclear comes in to really meet that requirement. We must remember that we are in the age of climate change. When a government spokesman, we might wake up one day and find a river that has been running for many years, running dry, and probably it was one that was running our plants. We must be very cautious and plan for the future so that we are not surprised.
Actually, that's true, because the river that I used to fetch water when I was small, Ruido River,
yes,
other people call me Modongo Ruido, it's actually true, it has actually shrunk. It's now a stream. It's really becoming smaller and smaller as days go by.
Yes, and therefore we have to have a source that we are much more in charge of. We know that wind and solar are intermittent. They cannot support serious industrialization.
Okay.
And therefore we need we need nuclear.
So nuclear is more consistent.
Nuclear is very consistent.
But people still feel about the Chernobyl, accident. The Hiroshima and Nagasaki.
Yes,
they linger.
Hiroshima and Nagasaki were not accidents. Those were deliberate use of nuclear technology for destruction and killing in a war scenario. But as I've mentioned, today's we have an international treaty which requires that all countries with nuclear arsenal should undertake disarmament.
Okay.
So that the countries with nuclear weapons are supposed to start to be destroying them. And those that don't have nuclear arms are not supposed to pursue development of nuclear weapons at all. So the only mandate that countries can do with nuclear is for peaceful uses. And therefore, in regards to accidents, yes, we had an accident in Chernobyl, but that, as has been pointed out, was an accident. And because of what was learned from that accident, the current technology has addressed the things that led to that accident, and it's not likely to happen again.
Very good.
Thank you very much. And when it comes to the cost of nuclear power, is it cost effective? Yes, nuclear is cost effective, but we must say this, that nuclear, I like comparing nuclear to, like, if you buy a plane. A plane is very expensive at the beginning, but a plane will take you to far places at a costly price. For example, if you were to go from here to New York, would you rather go by a bicycle or a car, or will you go with a plane? The plane will easily take you there in a shorter time, and you will be able to do your things. The same thing with nuclear. Nuclear is expensive at the beginning. The initial capital cost is very expensive. But we're talking about a project that is going to serve you for about 80 to 100 years. Yet, this is a project that is able to repay itself within 15 to 17 years, so that the remainder of the years, it's a bonus project. And the operation and maintenance cost for a nuclear power program is very, very low compared to other sources. Therefore, when you look at it, you find that most other sources, some of the best that we have, like geothermal, are going to give us electricity at 13 cents per kilowatt hour. But nuclear, when you do an analysis, is going to give you at about 8 cents per kilowatt hour.
So it's much, much cheaper.
It's much, much cheaper.
Yes.
And
what about electricity?
In the long term. And it will give you steady, stable supply.
What about electricity? How much do we get per kilowatt?
You will get the amount that you require it's stable, as in you don't, it doesn't go up and down. Yes, exactly.
Yes, load shedding.
Yes, there's no load shedding. So it is really reliable. It's like when you're doing rain-fed agriculture and irrigation agriculture. When you're doing irrigation agriculture, you don't go sleeping and just hoping. You know that you will have provided the plants with the water that they require, and they will grow. But when you're only depending on the rain, if there's a drought, then you're likely not to have a harvest. But with nuclear, you will get what you expect at all times. Yeah.
The Rolls-Royce Small Modular Reactor is a radically different approach to delivering new nuclear power based on proven technology and building on an unrivaled heritage of engineering excellence. Rolls-Royce SMR's unique factory-built approach significantly reduces on-site construction compared to conventional large nuclear projects. This cuts both time and capital cost and increases delivery certainty. Each power plant will be constructed from millions of components and hundreds of individual modules, with some of the most complex, high-value and safety-critical systems produced in the assembly and test factory. For Rolls-Royce SMR, modularization means that activities normally carried out on construction sites can be moved to the safe, predictable, controlled environment of a modern factory. Our operations will use the very latest data-led digital manufacturing techniques and simulated virtual environments to improve safety, efficiency, and program certainty, providing full traceability and quality control. The factory will employ hundreds of highly skilled operators with skills including welding, testing, and non-destructive inspection. Completed modules will undergo a series of tests before they leave the factory, assuring correct assembly and the highest standards of safety and performance. Functional tests of completed modules that would conventionally happen during power plant commissioning will be completed in the factory, providing manufacturing quality assurance and a predictable delivery schedule. Rolls-Royce SMRs are essential to reaching our net zero targets and addressing the global energy challenge. Our factories will set new standards for environmental performance. They are designed to put sustainability first, aiming for the lowest carbon footprint with the most sustainable use of water and materials. Developing an engaged, passionate, and motivated workforce is an essential part of delivering our mission, and we are committed to providing rewarding, long-term careers. Rolls-Royce SMR is striving to be an inclusive employer, developing a world-leading culture and creating a fantastic place to work. We want our factory to become an integral part of the communities where we operate, providing a unique opportunity to join us on our journey. Rolls-Royce SMR, providing clean, affordable energy for all.